Hi and welcome to the demo lesson about data processing modes in streaming. So just to remind you, here we will see element-based and microbatch-based processing with respectively Apache Flink and Apache Spark structured streaming. To start, let's begin with Apache Flink and the element-based processing. So here we have, maybe I will start with the data generator. It's very simple generator. I'm recreating the topics first, and later I'm generating some data, some letters with numbers to the created topic. So that's very easy. I'm using Apache Kafka Producer. And here for the element-based job, it's a little bit different. It's a little bit different because so far we have been working with Apache Spark. So you certainly recall all the setup part with Spark session. You recall all the data processing mode, which is very functional based with mapping, filters, flat maps, and any other constructs. And you are maybe not well familiar with what and how to define these parts with Apache Flink. So I will give a quick introduction here. We have a little bit Spark session-like object which is the stream execution environment. I'm creating here a local environment and I'm defining the parallelism to 2. Later on, there is a part about Apache Spark source where I'm defining a Kafka source for Apache Flink with I'm sure you recall this configuration. So I have the bootstrap servers, I have the first offset for the first execution, and also the topics and the deserializer. Later on, I'm initializing the loading and I'm applying the transformation. So the transformation is also a map function, which also exists, by the way, in Apache Spark. But under the hood, the processing is a little bit different. And later I finish this part with the sync, and the sync is a sample print console, and I'm blocking the execution because it's an unbounded data source. So to demonstrate why Apache Flink is an element-based, it's a quite challenging topic currently because it's hidden very deeply in the framework. And I will just show you an answer from Fabian Huesque, who is one of the project PMC, and who for me gave a quite clear explanation on the processing mode of Apache Flink in one of his Stack Overflow answers. So as you can see, Fabian says stream processing mode is different from Spark streaming. Spark structured streaming is the same, which is centered around mini aka microbatches. So whereas Flink data stream programs continuously process records. So for me the difference is in terms of volumes. I called Apache Flink as an element based because it processes data continuously and it takes less data than Apache Spark, because Apache Spark you can define the trigger that will execute roughly every minute, and every minute obviously you will take a huge amount of data compared to this continuous and small based processing of Apache Flink. So that's why it's called element based, because it was not very clear and it was not very easy to demonstrate in the demo, knowing that Apache Spark also has this map method that you can apply on top of one element. But anyway, let me set up the project. I will start also Docker containers right now. Okay, and in my Docker container I have only Apache Zookeeper and Apache Kafka because I'm on the previous version. All is starting, and I will later run my data generator and the and the element-based processing job. So I will now start the data generator, and as you can see it's purely in Java because Flink relies mostly on Java and not necessarily on the Scala as for Spark. There are some differences in the community, but I will not discuss them in this demo. And now I can start the element-based processing job. Logically, we should see the process data printed on the screen. So we have our letters, we have our dates, of course in UTC, and it processes them as once. We can see this fact of processing data at once with different milliseconds in the timestamps. And generally that's all for this Flink and element-based processing. So I will stop the generator right now, and I will open the project, which is for Apache Spark microbatch mode. And here the idea is very similar. We have our data generator, exactly the same but with Scala, but the data processing job is a little bit different. So in this data processing job, I will rely on the checkpoint to show you the microbatch aspect, and I will also rely on this map partitions processing to show you the same microbatch aspect. So Spark, because of its microbatch nature, has this map partitions method, where generally if you look at the Scala doc, you will see that it returns a new dataset by taking an iterator of items from one partition, one task partition, and returns another iterator, maybe of different items, for still remaining on the same partition. So it means that Spark takes some data, puts them to the single, I would say, task slot, and later process them at once, without necessarily looking for new data at this time, because data is read before the processing. And for the checkpoint, I will just run the code and show you later why I'm considering this as important. So let's do the setup first. I will just keep it running for some time. Okay, we're generating the records. And now I will start my job. Okay, we have already some data processed. You can see that we have here the same timestamp but different generator numbers, which proves that we process this all data on the same partition, and means also that we took this data at the same, we loaded this data at the same time from the partition. So I think I processed already some batch of records. I can stop it, and I will also stop. Oh, sorry, I wanted to show you something on the UI, but still I will maybe start by the checkpoint. So for the checkpoint, oh yeah, I will go here. I will show you the checkpoint for the offset number first. So that's not a good command. Okay, and what does it mean? Spark has some metadata where it stores the offsets processed in its microbatch, and here you can see that it processed up to 24 offsets, meaning that 24 records. When we take a look on the second one, you can already see that we processed 6 additional records. So let me give you a look at this. So in the first microbatch, more than 20 records, 6 records in the second microbatch, and if you look at the third, you can have 6 next ones, which means generally that Spark takes more. This streaming semantic is most like batch semantic. When we take some data that is available so far, we process it and we continue. Whereas in Flink is a little bit much more continuous, and I would say element based, but because of the reason I gave you previously. So I wanted also to show you the UI, so I will restart the job. So no, I will not restart the job, sorry. Data generator, okay, I will clean the checkpoint to avoid data loss error. We'll maybe do it from here. Okay, and now I will restart the generator, and I will also restart the job. So generator is starting, I will, okay, and I will also start the job and try to refresh the page where Apache Spark shows the job progress. And here you will clearly see in the structure streaming UI that we talk about the number of rows, we talk about batch, so number of rows per batch. You can see that we are processing various numbers. Of course, the first execution is always the most heavy one because is always the heaviest because it takes the most data available so far. And later we take 2 records, maybe a little bit more 6, and 6 is a quite of constant number. So that's another proof that the processing is it's more batch based than the element based in Apache Spark compared to Apache Flink. Thanks for watching and see you in the next lesson.